Yeah, I don't know why that did that. Okay, let's start this new the part two of going through this, and this will take us up to part three, which will be the last part of it. So let's practice. All right, so the frictional force looks like this. It's F of K. All right, gosh dang it. F of K, that's the way we write it. Frictional force is equal to that coefficient of kinetic friction, which we find by experiment and things like that, times the mass of the object times gravity. Okay, where this is actually the weight. Mg is actually the weight of the object. All right, so let's practice. Frictional force of a skier on old woody skis and wet snow. The skier has a mass of 58 kilograms. Oh, so M equals 58. The coefficient of kinetic friction with the woods, U of K, is equal to 0.1. And notice there are no units for the coefficient of friction. What is the kinetic frictional force? Well, F of K is equal to 0.1 times 58 times G, which is the acceleration due to gravity, 9.8 meters per second squared. Okay? Now, let's say Michaela Sheffrin has a mass of 60 kilograms. All right, so there we go. Mass of 60 kilograms. And we've got a kinetic frictional, the coefficient of kinetic friction. See, these are all big fancy words, okay, that I can see why it's hard. You know, these are just, to me, just normal things. Okay, and so what is the kinetic frictional force opposing Shiffrin's motion? So F of K is equal to, once again, mu of K times mg. And everything's there. Remember, G is always the same. As long as we're doing the problems on Earth, it's 9.8 meters per second squared. Now, Shiffrin coasts to a stop. Okay, so that this force, so let's say she's skiing down the mountain here with her poles, holding on to her poles here, skiing along, and she's going this way. Her velocity is going this way, and it's slowing down, and the frictional force is opposing her, going that way. All right? So she's going to have a change in kinetic energy. All right? In other words, her kinetic energy, her velocity is going to go to zero. All right? And she's going to eventually come to a stop. Okay? So if she's traveling at 15 meters per second, okay, what is her, and so her change in kinetic energy is going to be, her change in kinetic energy is going to equal 0 minus 1/2 her mass, 60, times 15 squared. So some of your classmates missed that 15 on their paper, but that's easy to do. And that'd be in joules. And I asked for the magnitude, and so the magnitude of it's always a positive number. If you give me the negative, that's fine too. All right, so on your calculator, just punch in 0.5 times 60 times, if you just wanted to do it the real easy, the non-mathy way completely, that'd be the way to do it. Okay. And you'll get around, I think, 6,070 joules, 6,270. I can't remember exactly. Okay, now in problem 10, we calculated, in problem 9, we calculated the force acting on her skis. Okay, if you calculated this thing correctly. And then we know that force times distance equals the change in kinetic energy. All right, and so what is the force? So how far is she going to go? So if I've got the kinetic frictional force times the distance that she goes is equal to what you got, her change in kinetic energy, which is your answer up here, then her distance, you can just take the answer up here and divide it by the answer you got in 10. So her distance becomes answer in 10 divided by the answer in 9. Okay. Now, To be honest with you, this would actually be a test question that I'd have on my Physics 210 class, easily. And there might even be some things. There might be a few things missing. They might even have to go up an angle to make it a little bit more tricky. But this is Physics 210. I just realized. All right, so let's look at Felix Baumgartner's part B. Next is Bugs Bunny.